All right, guys, we are going to do an example of how do we multiply matrices. And this is going to go through the whole entire process. The first thing we're going to do is we're going to write down the actual dimensions of the matrices. So for example, A is a 3 by 2, and B is a 2 by 3. And what that means is a 2 rows, 3 columns, and A has 3 rows and 2 columns. And then what I'm going to do is I'm going to write them right below the order of which we are going to multiply them. So A is 3 by 2, B is a 2 by 3. And the reason why we do that is in order to multiply, we need to make sure that the interior dimensions here are exactly the same, and they are. And that means we get the joy of being able to multiply. And what we should have here is a 3 by 3 as our result. Okay, so with that being said, now what I do is once I know I can multiply and I know what size matrix I should get, I'm going to go ahead and write down the matrices right next to each other. So A, I'm going to write that first as 1, 2, 3, negative 2, 0, 1. And then I'm going to write down the next matrix, which is negative 3, which is matrix B, negative 3, 5, negative 1, 2, 2, and negative 1. Now, what I want to pay attention to is exactly the size matrix that we should get out of here. Okay, and the size matrix that we should get out of here is a 3 by 3. So when I draw my answer, my resultant matrix, what I'm going to do is I'm going to make sure that I pay attention to the fact that it is, in fact, a 3 by 3. And I like to go ahead and just make my lines and fill them in because it will be a lot easier to do that. Now you will notice that I am putting some marks right there to do the math. So what I'm going to do here is I'm going to start, the way we multiply our matrices is we start with the first column of the second matrix. And what we do is we just take them, put them right on top, and I like to write the numbers right on top. Okay, and it is simply an addition and multiplication problem. I know that sounds really weird. So what we do is we take the negative 3 and the 5, and that was the first column. And that's why you see it in orange right here. We're going to be working in the first column. And what I do is I just write negative 3 times 1 plus 5 times 2. Okay, now it is still the first column, but I'm going to go to the second row now, and that's going to bring me to the second row right there. And I'm just going to write negative 3 times 3 plus 5 times negative 2. Okay. Once we've got that, I'm going to go to the, I'm still in the first column. I'm going to go to the third row. So it'll be negative 3 times 0 plus, and then I'm going to write 5 times 1. Okay. And I'm just going to leave those as equations right now. We can simplify them in a second. Now, I have now finished the orange column. I'm going to go to the green column. Now, in order to do this, I got to pay attention to the fact that I am simply now going to be working in the second column, or I'm going to be using the second column now. Okay, I'm going to be using the second column, and because I'm using the second column, all of my answers are going to go in the second column. And I'm going to bring this right over the top. I'm going to place it over the top, and I'm going to do the exact same thing that I just did. I'm going to take negative 1 times 1 and 2 times 2. So negative 1 times 1 plus 2 times 2. And then that is the first spot. I go the second column and the second row. I'm going to do the same thing. Negative 1 times 3 plus 2 times negative 2. Okay, and then I'm going to do the same thing. I'm going to go to the third spot, negative 1 times 0 and 2 times 1. So negative 1 times 0 plus 2 times 1. Okay, and then we just keep working. Now, you can kind of see the pattern of how this works. I am completely done because I brought that second column to every one of those rows. I am now going to do the last column, which is right here. There is our last column. And because of that, we are in the last column. I'm just going to bring those right over the top, 2 times 2 and -1. And I'm going to do the exact same thing. It's the same pattern, 2 times 1, -1 times 2. 2 times 1 plus -1 times 2. I'm going to do 2 times 3 plus -1 times -2. Okay, and then I'm going to do 2 times 0 plus -1 times 1. Okay, now I've written all this out, and all we're going to do at this point is we are going to simplify in order to get the nice 3 by 3 that we are looking for. Okay, and so this should be pretty simple. You're just going through and doing the math for each one of these spots. So -3 plus 5 times 2, 5 times 10 plus -3 is 7. -3 times 3 is -9. 9 plus 5 times -2. So we got -9 times plus -10 is -19. We've got -3 times 0, which is 0. 5 times 1 is 5. So this is just going to be 5. Okay. And you can use Desmos, you can use a calculator to do this, but you're now just simply finding all the pieces. So -1 times 1 is -1, plus 2 times 2 is 4, so that is 3. -1 times 3 is -3, plus 2 times -2 is -4. There we go. That is going to be -7. And then we get -1 times 0 is 0. 2 times 1 is simply just going to be 2. And then we just work our way all the way through until we've answered all of those spots. So 2 times 1 is 2. -1 times 2 is -2. That is going to give us a 0 when we add them together. 2 times 3 is 6. This is a -1 times 2 is 2. 6 plus 2 is 8. 2 times 0 is 0. -1 times 1 is -1. And that is going to be -1. Now, those are going to be our solutions. So once again, what we want to do is we want to check to make sure the interior dimensions are the same. And then now the exterior portions will tell us the dimensions. Then we are going to line them up next to each other. And I like to go ahead and make the size matrix that we're going to have. And then once again, just following it, we bring the column over the top and we just work our way down. And as we work our way down, that is going to fill out each specific spot in the matrix. And of course, once you figure that out, you need to go back and clean it up and make sure that each one of the sections of the matrix are filled completely in. All right, I hope that helps with multiplying matrices.